So here we're discussing how many molecules are polar out of SO3, OF2, BeCl2, CCl4, and O3. Our steps will be to draw the Lewis structure, to identify bond dipoles using differences in electronegativities, and to identify net molecular dipoles based on molecular geometries. So our first atom is SO3, and it has 24 valence electrons, and we get that from multiplying and adding the valence electrons together. And we draw this Lewis structure for it. Sulfur is one of the atoms that violates the octet rule, so it can have more than eight valence electrons. And so we fill in the rules for the rest of the atoms, and then we plug in the partial charges, which is negative on the outer ones and positive on the inner ones. And so here we're going to determine that we have three domains, 1, 2, 3. And 3 domains makes it trigonal planar. And then we have to draw out the molecular geometry. And so here we are going to draw the bond dipoles, and they go from the from the less electronegative atom to the more electronegative atom. And so these 3 dipoles will cancel, and making SO3 nonpolar. Next, we have OF2, and OF2 is going to have 20 valence electrons. Because it is 6 plus 7 times 2, which is 20. And then we're going to draw the Lewis structure. And so here we have partial negative charges on the fluorine atoms on the outside and a partial positive charge on the oxygen atom on the inside. And here we have 1, 2, 3, 4 domains. 4 domains as domain geometry, that means it's tetrahedral. But we also have 2 non-bonding pairs. So that means it is bent. And so we have to draw the molecular geometry for it. And this is it. So as you can see here, we have the two bonds and the 2 pairs of non-bonding. And then we're going to draw our bond dipoles. The dipoles do not cancel because there is a net dipole that goes down, and so which makes this molecule polar. Next, we have BeCl2. BeCl2 has 16 valence electrons. Here we're going to start with the Lewis structure. Filling in octets on the outside atoms first, and then counting to make sure. And that makes 16 electrons in total, 2, 4, 6, 8, 10, 12, 14, 16. And we're going to count the domains around the center atom. So we have 2 domains, which makes this linear. And so the CLs on the outside have partial negative charges, and the Be has a partial positive charge. We're going to draw the bond dipoles. They go in from the inside to the outside, from the least electronegative to the most electronegative. And so the dipoles cancel, which makes this nonpolar. Our next atom is CCl4. We're going to draw the Lewis structure. Filling in octets around the carbon. All of the chlorides have a partial negative charge, and the carbon on the inside has a partial positive charge. We have 32 valence electrons, because we have 7 times 4 plus 4, which is 32. And so then we're going to count the domains. 1, 2, 3, 4. We have 4 domains. And so that means it's tetrahedral. And then we're going to draw the bond dipoles. And so we have one that goes up, these that go out, and this one that goes into the paper, but we're going to draw it going out. And so all of the dipoles cancel, so which makes this not polar. Lastly, we have ozone, which is O3. And we're going to begin with a Lewis structure. O, double bonds to an O. So this one is tricky because it is bent. It has a sort of misshapen Lewis structure. So the top part of this is going to have a partial positive charge, and the bottom part of this is going to have a partial negative charge towards the bottom, because they have more electrons than this middle atom, and so that's being pulled to the top. And then we're going to, as usual, we're going to count the molecular geometries. The domains. 1, 2, 3. And 3 domains. In domain geometry, that means trigonal planar, but since we have one non-bonding, it is bent. And then we're going to draw the net dipoles. And so, because these are 2, we're going to have one net dipole that goes down. And because there is a net dipole, they do not cancel, and it is a polar molecule. And so to go back to the beginning, where how many of these molecules are polar? SO3 was not polar. OF2 was polar. BeCl2 not polar. CCl4 not polar. O3 polar. And lastly, to discuss some mistakes to avoid, you must correctly be able to draw the Lewis structures, because that is the base of this whole idea and this whole concept. And if you can't draw the Lewis structures correctly, then everything that follows it will be incorrect. And you should be able to either look at an electronegativity chart on the periodic table or know electronegativities and how they work on the periodic table to be able to draw the bond dipoles and what direction they go in order to determine polar or nonpolar.